All right, today we're diving into something that sounds like it's straight out of science fiction, but it's happening right now. We're talking about the incredible way artificial intelligence is learning how to save lives by diagnosing brain tumors faster and more accurately than ever before. And that really brings us to the central question, doesn't it? Can a piece of software, an algorithm, actually look at a super complex MRI scan and see what a highly trained, experienced doctor sees? Well, the answer is pretty amazing. So, to really get why this is such a big deal, we have to understand the challenge itself. When you're dealing with something as serious as a brain tumor, it is a literal race against the clock. Every single minute, every second matters. I mean, just think about it. You have a radiologist, someone who has spent years and years training their eyes to spot the tiniest anomalies. They have to pore over these incredibly detailed scans, and that process, it can take hours for just one patient. The pressure to be fast, but also to be 100% right, is just immense. Okay, so this is where AI steps onto the stage. But let's be really clear about something. This isn't about replacing doctors. Not at all. It's about giving them a superpower. Think of it like the ultimate assistant, a tireless, super fast second opinion that helps them do their job even better. So how does it actually work in a real clinic? Well, it's surprisingly simple. A technician just uploads the patient's MRI scan. The AI gets to work analyzing that image in, well, basically an instant. And then boom, it delivers a diagnosis, even telling you how confident it is. A process that took hours now takes literally seconds. Okay, so that all sounds fantastic, but how? I mean, how on earth can a machine learn to do something so incredibly complex? Well, the magic behind it is a technology called deep learning. So let's kind of peel back the curtain and see how it works. The real secret sauce here is a concept called transfer learning. Here's a way to think about it. Imagine a brilliant detective who's solved thousands of different cases. They already know how to spot patterns, how to find clues, right? So if you give them a new type of case, they don't have to start from scratch. They just adapt their existing skills. That's exactly what the AI does. It's already been trained on millions of random images of cats and cars and trees, so it already knows what shapes and textures are. Then that knowledge is fine-tuned to make it a specialist in one thing, finding tumors. And, not all AI tools are created equal. You need the right tool for the right job. On one hand, you've got a model like VG16. Think of this as the heavyweight champion. It's built for raw power and the absolute best accuracy. On the other hand, you have something like MobileNetV2. This one is the lightweight, nimble specialist. It's designed to be so efficient it can run on a tablet or a phone, bringing that diagnostic power to literally anywhere in the world. So, the big question, how well does this stuff actually work? Because it's one thing to have a fast, clever system, but in medicine, accuracy is absolutely everything. So let's really look at the performance numbers. That flagship model we were just talking about, VGG16, it hits an accuracy of over 84%. Now, to put that in perspective, it means that in more than 84 out of every 100 cases, it correctly figures out if a tumor is there or not. For an automated system to do that, that's seriously, seriously impressive. But just being accurate isn't the whole story. This is where it gets really important. There are other things to measure. First, there's precision. This is about avoiding false alarms. You absolutely do not want to tell a healthy person they have a brain tumor. That's a devastating mistake. Then there's recall. This is the opposite. It's about making sure you don't miss anything, that you catch every single tumor that's actually there. A truly great AI has to be a master of both. So this technology is clearly more than just a cool research project. It honestly has the potential to completely change how we deliver healthcare, not just in big cities, but all around the world. I mean, the possibilities are just staggering. Think about telemedicine. Someone in a tiny, remote village could suddenly have access to world-class diagnostic expertise. Or in a chaotic, busy hospital, the system could automatically flag the most urgent cases so they get seen first. For researchers, it's a tool that can sift through thousands of scans to find new patterns and diseases. It is a genuine force multiplier for all of medicine. And really, if you take just one thing away from all of this, let it be this quote. This is the absolute game changer. Taking a process that requires hours of an expert's precious time and crushing it down into seconds. That frees up doctors to do what they do best, spend time with patients and focus on treatment. And make no mistake, this isn't some pie-in-the-sky idea for the future. It is happening right now. The market for AI in healthcare is absolutely exploding. It's projected to be worth over $32 billion in just a few years. That's not a trend, that's a revolution in progress. So, as we see AI become this essential co-pilot for our doctors, it really leaves us with this one fascinating question to think about. If it can help us find brain tumors in seconds, what other giant medical challenges are we about to solve next?